This video is designed to be an introduction to the formatting of scientific notation. So the basic format is that you would have a leading digit, so I've written in 3, and the leading digit must be a whole number from 1 through 9. This number is essentially 3 times 10 to the something. I'm going to pick 4 in this case, which means that we've essentially written the number of 3 followed by 4 zeros. In other words, the exponent tells us what power of 10 column the leading digit belongs in. 10 to the 4th is 10,000, so what we have is 3 10,000s, or 30,000. Now, if we were to write some significant digits in there after the decimal place, in other words having 3 significant digits now with the 2 extras after the decimal place, what that says is we know the number more accurately, and so what we know is that the number is 30,000 with a 32,700 details added in. However, keep in mind that the 10 to the 4th still tells us that the 3 is in the 10,000s column, and the 27, or the 0.27, is simply more details that we know this number more accurately. So to take a couple of examples, if we have the number 26,000, the 2 is in the 10,000s column, which is a 1 followed by 4 zeros. So we would write it as 2.6, because we know the 6,000s, times 10 to the 4th. What that tells us is that the 2 is in the 4th column, meaning it's in the 10,000s. So we have 20,000, and we have a little bit more because of the decimal 0.6. That 0.6 is basically telling us we have 6/10 of a 10,000, which of course is 6,000. So let's take another example. Let's look at the number 452.7. Now this is the approximately the number 400, so it's approximately 400, which means it's a 4 followed by 2 zeros. So this number turns into 4 times 10 squared, but since we know it more accurately, we write it as 4, we actually write our original number as 4.527, all digits that we know, also times 10 squared. Because it's the same size number, which our exponent tells us. So it's either 4 times 10 squared, which is approximately 400, or 4.527 times 10 squared, which is the number 452.7. Finally, just as a brief mention, a decimal, something smaller than 1, is going to be written using negative exponents because you're actually dividing by 10, because you're in the tenths or hundreds or thousandths column. So if we take the following number, 0.0034, and we look at that, this is approximately 3 1,000ths. We are in the thousandths column, which means we should be dividing by 3 tens, which means we write the number as 3 times 10 to the negative 3. And by the way, we know this number a little more accurately, so it's actually 3.4 times 10 to the 3rd. Another way to think about this in terms of getting efficient at writing this is to say, how much did I have to move the decimal over? Well, I moved it over 3 decimal places, which means I had to divide by 3 tens. So the negative 3 in the exponent is simply telling you that you're dividing by 3 tens rather than multiplying by 3 tens. So I will show you how to fix some answers in scientific notation and also how to multiply and divide in scientific notation on a subsequent video.